Hi, good morning, everybody, and welcome to yet another episode of New Breakpoint. My name's Simon Waite, and it's really great to be with you today. If you'd love to join our show today, go over to our YouTube channel on the link that's on the screen at the moment, or hit us up on Twitter at Microsoft AU Dev at any time with your questions or feedback on the show. If you like what you see today, please make sure to join our monthly email newsletter. Follow the link there that's on the screen. And as always, if you are wanting to join in, make sure you're doing it in a way that is appropriate and respectful of everyone who's a member of our community. Really excited for today's show. We have a really excellent episode lined up for you and a couple of special guests as well. To get things kicked off, I'm going to bring on Kris. Kris Bock is a member of our Azure Fast Track team focused on machine learning and data science, and he's been doing some great work with the folks that we've got on today. So let me bring Kris on. Hey, Kris, good morning.
Morning, Simon. How are you?
I'm doing well today. Look, I remember seeing and hearing about DrumBeat.ai last year when I was doing some work with our AI folks here in Australia, and really excited to see that we've been engaged with the folks that are working in this space. Maybe, do you want to give us just a little bit of an insight into DrumBeat.ai and our involvement and your involvement, I guess, in the work with the folks that are running this program?
Yeah, sure thing. I'm glad to. Thanks for having us on to talk about this project. It's really exciting. DrumBeat.ai is essentially a project that aims to leverage AI and machine learning to reduce or remove ear disease that's endemic in Indigenous populations in Australia. I'm not sure if the audience knows, but out in rural and remote communities, the prevalence of ear disease in kids in Indigenous communities is quite high, and to the point where the World Health Organization has called it endemic. And the team are using AI and ML to basically classify images that are taken using an otoscope to really speed up that time for diagnosis and treatment. It's a great project. And so largely my involvement has come from helping the team, who consist of ENT, that's ears, nose and throat surgeons, and doctors and researchers and clinicians, and helping them to bridge that technology gap, I guess, to help understand how they can use the Microsoft Azure tools and solutions to create it.
And we were lucky enough to catch up with a couple of the key investigators behind this program of work. I was going to say, unfortunately, they can't join us today, but when you and I caught up about today's session earlier, you said, actually, fortunately, they can't join us today because they're off doing their day jobs, right? The important work that they're doing. So we did have a chance to pre-record an interview with them. Do you want to help set up the interview a little bit and talk about the folks that we're going to be bringing on?
Yeah, thanks. It's key here to understand this isn't just AI looking for a solution. This is definitely a problem that we have. And really, the conversation with Professor Singh and Dr. Habib is to help set that context, is what is the real problem? What are we trying to do here? And also, to put it more appropriately, this is an example of AI trying to augment or enrich the capabilities of world-class surgeons or ENTs. And so I think the key here is trying to understand exactly how AI can help. And so if you've got the clip, let's roll it.
All right, okay, let me bring it on. And so please hang around. This is an amazing discussion with a couple of folks that are really passionate about healthcare. And I think, to Kris's point, it's really showing how we advance humans through augmentation of expertise. So look, please hang around. We'll be back after the interview to go do a run through of how Azure fits into this picture with Kris. So let me bring this up and we'll start that now.
Now I'm joined with Dr. Rahim Habib and Associate Professor Narinder Singh to talk in detail about the DrumBeat project. If I just start with introductions from yourselves, can I start with you, Dr. Rahim?
Thanks, Kris. So my name is Rahim. I'm one of the ENT surgical trainees working here in Brisbane, the Princess Alexandra Hospital and the Green Slopes Private Hospital. And I'm also a PhD candidate at the University of Sydney. I'm working with Prof on the DrumBeat.ai Project.
And Dr. Singh?
Thanks, Kris. My name's Narinder Singh, and I'm an Associate Professor of Surgery at the University of Sydney and the Head of Department at Westmead Hospital in Sydney. And I'm an ENT surgeon, that's ear, nose and throat. and involved in the DrumBeat.ai project.
Thank you. And fascinating. I think one of the things really I find fascinating about this project is the intersection of really clinical and diagnostic medicine with leading edge technology. And so I guess if I could just start with a little bit of a question of the project itself and really how you got involved with that. Start with you, Rahim, if that's okay.
Yeah, no, thanks, Kris. I think it was something that Prof. Singh and I had been discussing in detail, but how to intersect technology and this advanced kind of AI methodology and accessibility and apply it into an area where there's a health discrepancy and an underserviced community. We had spent some time with our colleagues from Northern Territory really learning a little bit more about the telemedicine and teleotology network and how children from rural and remote areas are evaluated by an ear, nose, and throat surgeon. And collectively, we realized that this is an area that has tremendous promise and can do a significant amount of public health good. And we can apply this advanced technology to some of the most underprivileged communities. So that's really where the project started from.
Right. And I guess if we just take a step back, so the goal here is to use artificial intelligence and AI to classify images that are taken out in the field. Is that correct?
Yeah. So Kris, so I guess stepping back a little bit, I know the technology is what we're here to discuss and is the most interesting part of the project. But as you say, stepping back and looking at the clinical problem that we're facing, one of the things that a lot of us don't realize is that ear disease, chronic ear disease, long-term ear disease in Aboriginal and Torres Strait Islander children in Australia is a real problem, particularly in rural and remote communities. So much so that we have the highest rates of ear disease in that group in the world. So the WHO, the World Health Organization, has called this a massive public health problem that requires immediate attention. And, you know, a lot of us think of ear disease as maybe a small ear infection that's easily treated with antibiotics, but we're talking about something significantly more serious than that. So with this particular condition, because it can last for a long period of time and can have significant detrimental effects on hearing, this can result in lifelong problems for the people affected. So it can result in affecting their communication, their development of language, their performance at school, their job prospects, and social isolation. So it really has lifelong devastating consequences and requires urgent attention. And Kris, one of the problems that this problem has been known about for a long time. So it's been identified by the WHO for over 50 to 60 years. And successive governments and people of goodwill have thrown inordinate amounts of resources at this problem to try and address it, with only marginal improvements in those disease rates that we discussed. And so really we need some novel and innovative solutions to try and address this problem. And this is where we saw the potential for artificial intelligence to actually come into that role.
Wow, that's yeah. I mean, that context just, I think, helps to align or helps anyone who's working in machine learning and AI to see what potential difference could be made and to the general good, right? So I think that's an amazing use case and really one I hope has a lot of success. So I guess you mentioned some of the money and the effort's been thrown before. Do we know, has anything been done like this using technology as a tool?
Yeah, it's great that you bring that up, Kris, because one of the problems that we have in addressing this issue is that ENT surgeons in general are thin on the ground, like myself, are thin on the ground. And in rural and remote communities, as you can imagine, access is very, very limited to ear, nose, and throat specialists, who are the specialists that primarily care for this type of ear disease. Since last year, in addition, the coronavirus pandemic has amplified that problem, because the risk of introducing the disease from a visiting metropolitan team of specialists into a rural and remote community would potentially be a devastating and have significant consequences. So that's just amplified the problem and made it worse. Now, really, one of the techniques that's been used over the years that actually has been beneficial in reducing the incidence of the disease is the use of telemedicine, so remote medicine. So that's where a local healthcare worker in the community can capture images of children's eardrums and make a recording of their history and their clinical findings, and then upload them to a database where a metropolitan ENT specialist in a remote in a city location can look at that data, look at the images of the eardrum, and then send the message back as to how that child should be treated. So that is an innovative use of technology that has actually had some benefit, but it has its own problems. So the main problems with that technique is that, firstly, it does introduce significant delays. So ideally, what we want to do is when the child is seen with ear disease, we want to act immediately, whereas with the telemedicine technique, we have a delay of several days or a week until the specialist actually reviews the images and then gets the message back to the remote healthcare worker. The other problem is that there are other issues as well around making sure we actually get back to the child, and it also means that then the specialist has a very tedious time looking through a lot of normal ear images. So as you can imagine, when you're actually seeing patients, that's one thing, but just looking at computer images can get a little bit tiring. So this situation then lends itself ideally to artificial intelligence technology. So if we can create an algorithm that can actually take a lot of the legwork out of that process, then there's a real potential for innovation in that it can then immediately set aside normal images, and it is an immediate point of care tool, so that as the image is captured, then an immediate diagnostic or triage information can be provided using the algorithm. So all of those things certainly set themselves up for this to be a revolutionary use of the technology.
Yeah, got it. Thanks. I mean, I understand certainly having the patient there and having the potential for an instant diagnosis is revolutionary, rather than kind of this offline methodology, like you said, which is currently is still yielding positive results, but does introduce potential lag. And then I guess the other benefit I see with AI would be that consistency of diagnosis, right? You've got an algorithm, it's basically will produce the same results repeatedly, so you're kind of removing that human invariance potentially. So distilling that ENT knowledge and expertise and capturing an algorithm, that's amazing. So I guess, where would we like to see this in the future? What would be the ideal outcome using AI to classify these images? What does it look like in the successful world?
Yeah, so Kris, a great question, and really where we would see this technology in its ultimate implementation, which we're a long way off, but we're heading in that direction, is we can imagine, for instance, a otoscope, which is the device that we use to look inside the ear. Either the otoscope itself, or perhaps the otoscope connected to a smartphone type device, which has the algorithm built in. So we can imagine a world where the remote healthcare worker puts the otoscope into the child's ear and is given an immediate information based on what the algorithm finds. And we imagine the one thing we don't want to do is replace the role of doctors and clinicians. This is a tool to work alongside the doctors and clinicians. So what we imagine is perhaps a traffic light type of system where, for instance, if the green light comes up through the algorithm, then we know that this child, most likely their ear is normal and can come back for review in a few months' time. Perhaps if there's an orange light, then we say this child perhaps needs to have some basic treatment and come back for review in a week or two. And then perhaps a red light where this child needs urgent specialist review. And that way, it rather than replacing the clinician, it allows it augments the use of the clinician. So it means that only the children that need immediate care are seen immediately, rather than the clinician seeing children that don't necessarily need care. So that's the long-term goal. There's many steps along the way, and there's a lot of experience that needs to be gained and testing that needs to be done. as you can imagine, anytime we're talking about healthcare and humans, then we have to be very careful to follow all of the correct ethical guidelines and make sure all of our testing is done appropriately to make sure that we do the best by the patients long term.
Yeah, excellent. Excuse me. I think that human in the loop concept is definitely something we always advocate whenever we're using technology. So because of the human and the outcome goal of this, I definitely think the merriment of AI and health work well. If I could just finally, Rahim, just ask a question. The focus of this is Aboriginal and Torres Strait Islands, Indigenous populations, particularly within Australia. But this has a global appeal, application, does it not?
Yeah, absolutely. If you look globally around the world, Indigenous communities do suffer from high rates of ear disease, but it's also the discrepancy in high and low income countries amongst marginalized populations. And there's a number of socio-demographic and cultural factors that stem to those health inequities, but an aspect of that is accessibility to tertiary care, or as Prof. Singh was saying, access to ENT specialists, audiologists who can provide valuable information in terms of hearing quality and hearing treatment. And so this application is just one of many which we can expand. Otoscopy is a commonly performed procedure, not only in frontline health settings, GP offices, emergency room departments, and often looking in the ear can vary with the number of ears you've looked at or the amount of experience that you have. So this is a wonderful opportunity where we can, train these algorithms on thousands of images and really provide the user with more informed judgment in terms of the severity of the ear that they're looking at, so that on the ground, they can make a decision with a little bit more certainty and confidence. So you can see that application is not just for a rural healthcare worker who's working in an area that's underserviced, but also for a metropolitan healthcare worker who may not have enough confidence or experience in looking in the ear. So the applications can stem, and the issues that we face here in Australia similarly are faced around the world, sub-Saharan Africa, as well as other places that have that disparity between high and low income.
Awesome. Start local, spread global. What an amazing project. So just finishing on that, obviously being involved in this, it's I think an amazing part and one of the reasons I enjoy so much what I do. If I could just get some closing thoughts from you, Professor Singh, and then you, Rahim.
Thanks, Kris. So the DrumBeat project is we've worked on many research projects over the years, but this one is really hits home because it's so interesting and it's something that we actually has real benefit for a marginalized and affected group in our Australian community that really is desperate for our help. And it also has, as Rahim mentioned, it has potential application worldwide as well in commercial areas. But our main goal, of course, is to address our Indigenous communities, but we'd be happy to expand it to other areas eventually as well.
Yeah, I'll just follow up by saying that there's tremendous promise in this interaction and intersection between advanced technology and clinical use and frontline applications. And I think it's exciting to think that we can take some of the most intuitive advanced methodology and apply it to populations that have very poor access to healthcare. So to be able to bridge that gap and provide another level of service to these people is quite remarkable. I think it's also exciting as we expand our model to think about how we can not only reallocate our resources, but focus our attentions to other aspects that may require a little bit more support. We can improve triage, but then what's the next step? How can we improve treatment? So I think it's kind of really exciting to grow this project and be involved with it, and also think about the possibilities that can come from it.
Awesome. All right. Well, thanks very much for your time. Appreciate you're very, very busy, and to take you out of the sort of clinical environment and then have a chat on Breakpoint is much appreciated. Thanks for your time.
Great. I think that's a great oversight from my standpoint. Oftentimes in the job that we do, as technologists, we can feel a little bit removed from that sort of human impact of the work that we're doing. And I think that that's a great discussion to show the opportunity that technology has to play here. And I think also, you know, to Professor Singh's point in that conversation, you know, doing AI and doing it ethically, particularly when it relates to humans and healthcare, is all important. And I know, Kris, you're probably far more familiar with it than I am, given the job that you do. But you know, the responsible AI story that Microsoft has is, I think, quite an interesting and unique approach to AI, which is ethical first and thinking about the impact of technology rather than technology first and then maybe thinking about the impact and ethics of that at a later point in time.
Yeah, absolutely. I mean, it's one thing. As techies, we love to get involved in cool and exciting things, but having that Ether panel, which is a Microsoft's AI and ethics panel, in front of our minds while we engage in these things is crucially important. And I think, you know, one of the nice things about this project is, you know, there's lots of concern around AI widening that digital divide or creating greater levels of inequality in society. And this is, you know, certainly the opposite of that. This is really an example of bridging that gap. And so hugely important work.
Okay, look, I know folks like to come to New Breakpoint to get a little bit of technical know-how. So I know that you've got a little bit of a discussion and a walkthrough about the high levels of the work that you've been doing with this. So let me pull up your diagram here. And what I'm going to do is let me just rearrange this so you're on top. So did you want to talk us a little bit through the process here? I can see things like Onyx, and I can see a TensorFlow logo and an Apple icon and a Docker icon. It looks like there's some interesting tech in here. Do you want to walk us through it?
Yeah, sure thing. I mean, largely, you remember the DrumBeat program is, because it's medical and healthcare, there's a large and rigorous process to get that through the necessary approvals. But underneath the technology that we're using to make this happen and I guess support the research is really quite straightforward. What we do is we can take an existing corpus of images. Now, the DrumBeat team of working with a couple of state-based organisations in Australia, Queensland Health and the Deadliest program and the Northern Territory government, and they've got access to a range of images that have been captured over a number of years, and they take those images and they feed them into the custom vision service, which is our computer vision machine learning service, which largely simplifies that experience for the researchers. Because at the end of the day, they're clinicians, they're not machine learning engineers or data scientists. And so what they don't need is to have to try to hand roll or code a lot of the models that they would use. So what they do is they feed this into custom vision. They can take the outputs from the performance metrics in terms of the accuracy, precision, and recall, and then they can write up or support their research behind it. So that's great from that part, from going through that process. Now, when we talk about the applied side, that's where the technology starts to shine. So there's a couple of ways that you can apply this. One way is you can take that custom vision model and just turn it into a REST service, a REST endpoint. And then you can have an application come along and just consume that, you know, submit an image and get back a diagnosis or a response. But looking further to Professor Singh's point, which is how do we reduce that triage time, which is, you know, can we embed the algorithm in the device itself? And again, that's where custom vision works really well, because you can export that model into a number of different frameworks. You can use TensorFlow or Core ML, which is Apple's, or the sort of vendor neutral Onyx format, or even deploy it to a Docker container. And then that exported model can then be, you know, built into an iOS application, or even rendered directly into that otoscope itself. So again, there's a whole range of different options to support that use case.
And I think it's the story that I like here is that every part of this diagram, maybe apart from pushing to the otoscope device itself right at this point in time, but every part of this workflow is something that you can do today as a consumer of the Azure platform, right? There's no special preview or locks on using this. So if you've got a use case that can do image recognition or classification, you can use this workflow. And I think the fact that we're able to, leverage the years of research and development Microsoft's done in machine learning through the things that Cognitive Services offers, to your point, really democratizes the use of AI, because you no longer need to be that machine learning specialist to understand how to build classification models, because you provide your test data, you run that through the system. You provide your training data, and then you've got your test data, and that's a fairly basic concept to understand, even if you're not an ML specialist, right? It's like, I've got this training data, and then I can test it using this data, and then once I'm satisfied that I'm getting a degree of accuracy I'm happy with, I can then export these things. And I think, it's not captured here, but there are things like versioning involved, so you can continue to iterate on that model over time and generate new endpoints and have versioned endpoints as well, and versioned models that are exported, so that you've kind of got that life cycle already available to you today. And I think you probably do a lot more of this in your day job than I do. So I think you probably see the positive impact of having these sorts of services available out of the box on a regular basis.
Absolutely. And it's not just the health domain as well. There's a whole bunch of environmental science work that we're doing. And again, the goal there is let the subject matter experts focus on interpreting the results of the classification, and not necessarily on, which framework version do I need to use to wire it up. It's having huge impact.
Yeah, that's a let the developers and the machine learning data scientist specialists worry about what version of PyTorch they should be using in their release today. All right, so let's pop that off, and I'm just going to chuck this up here. Just hang on the stream with me, Kris, for a few seconds while we wrap up. Look, I very much appreciate you helping facilitate today and the connection with Dr. Singh and Dr. Habib. Really enjoyed that discussion. Hopefully everyone watching along today got some real value and insight out of how, as technologists and increasingly AI and machine learning specialists or associates, shall we say, we can start to help impact people in real and meaningful ways. So, Kris, thank you very much for helping that today. If you are interested in what you've seen here today, the show notes have already been updated, and they've got links to the DrumBeatai Project site, some other information about the great work that they're doing with the state-based organisations like Kris mentioned, along with some information on the custom vision services and exporting models to things like Onyx. So, Kris, I wanted to thank you very much again today. We always try to end the show with a wave to everybody out there, so a quick wave to everybody out there. And look, thanks a lot for joining us again today, folks. We've got our last show of June next week, which will be on the AI podcast with the community team that's sitting behind running the Global AI podcast. So that's going to be awesome if you want to understand what it takes to start a podcast, what the Global AI podcast is actually about. I hope you can join us next week. And what I want to say is thanks a lot for now, everybody, and we'll see you next week. Bye for now.